Hello students, welcome again to ASOC Tutorials India program, a platform to learn amateur radio in India, and today's my session is in continue to semiconductor basics of amplifier. It is basics only and it is in parts, so listen and watch carefully. Today the first thing is what is amplifier itself. The amplifier is an electronic device that increase the voltage and current or power of a signal without changing its other parameter. Parameter means frequency, phase, amplitude, and its wave shape and other parameters. So there is no loss or no distortion, and increasing the strength of it is called amplifier. So amplifiers are one of the most commonly used circuits in the electronics and perform a variety of functions in many electronic systems. Everywhere you will find it. So the amplifier symbol gives no detail of the types of the symbol described. It only gives the direction of the signal flow and can be assumed as following from left to right in diagram. Just going to show you in the screen. And this one used in so many applications, maybe wireless or wired, your radio, your mobile set, your computer, audio system, video system, everywhere. Even in antenna signals weak in DTH, to improve that one, again it is used as an amplifier. So this can be categorized in several parameters. Going to explain you in later slides. First, see, this is a simple diagram showing input and output only in triangle format, but it is general. If it is operational amplifier or other, it will show two inputs and one outputs. That I am not going to explain you. It is not required in ASOC exam. Now going continuously. So based on number of stages, first depending on number of stages amplifier, maybe it is single stage amplifier where only I am using just one transistor. You can see on your screen with the biasing parameters that I am going to explain a little bit later slide, and there is an input also. This is a simple diagram how a transistor is configured, and this is input signal coming at the base and being amplified by Q2 and taking output from the collector. So now this one was single stage amplifier. Same one in multiple, in cascade format, we can use as a multi-stage amplifier. You can see this one with slightly changing some parameter. We can use number of stages in continue. So this is one thing. Now based on input signal, depend on magnitude of the input signal, we can say it is small signal amplifier for very weak signal, like on antenna, a very weak signal from microphone or a sensor. But once they are improved using cascade amplifier, we are going to again try some load like a loudspeaker, relay or other devices. Then we need a large signal amplifier. This is a powerful amplifier. Same way, based on its outputs, how the output we can use it. Voltage amplifier, if we are increasing the strength of voltage, and power amplifier or current amplifier, if we are increasing the strength of power to drive a powerful devices like relays, solid state walls and other parameters, we can use this kind of output. Even a powerful loudspeaker also. So based on frequency rate, that is very important, because frequency, starting from 0 DC, but I am saying about frequency, maybe audio frequency rate, you are right now listening, if it is a range from 20 Hz to 20 kilohertz, but somewhere we have lesser capacity to this type of amplifier called AF amplifier, amplitude frequency amplifiers. Same way, if using high frequency, radio frequency amplifier, they are using radio frequency. Same way, microwave frequency and other, and this intermediate frequency in between two. This one I am going to explain you when the radio receiver will come, not right now, but you can understand these frequencies in between radio frequency and audio frequency. So same way, if I am using amplifier for video purpose, it is video amplifier. If I am just isolating the circuit from 1 to 2, It is called buffer amplifier or isolator amplifier. So let's say the power amplifier for high output, ultrasonic amplifier for ultrasonic frequencies, DC amplifier if I am using for operational amplifier, linear amplifier, or some kind of amplifier used for like weight scale. They have very mini voltage. Thermometer, thermistors, these kind of amplifiers use DC amplifier. They have very limited voltage, plus or minus microvolt, and we have to improve the strength or your multimeter deflection coil. So this kind of amplifier are called DC amplifier. So many are there, these are enough for you to understand. But one thing remember, name of the amplifier is given on used frequency. So based on transistor configuration, if you remember in transistor topic, I have already explained you, depending on the type of transistor configure, there are common emitter, common base, and common collector amplifiers. And common emitter amplifiers means that the amplifier which formed using common emitter configuration, and same way common base configuration, same way common collector amplification, and they have different parameters. Already explained you in previous session. If you have not seen, kindly see that first, then only you will understand. I am not going to re-explain here itself. So now coming to the next parameter, based on biasing condition, how we are dividing base R1 and R2, giving specific amount of voltage, a proportionate voltage. That voltage is deciding this is a class A amplifier or class B amplifier or class C amplifier or AB amplifier. So just giving idea only, because I have to cover you in more details, their wave shape, their losses, their uses, applications, energy, etc. So please watch next session, that is purely on classification of amplifiers. So going next, based on coupling method, how signal is going? Maybe direct, simply giving via resistance, via inductance, or via capacitance. Even we can use transformer also. So based on these parameters, we can say it is RC coupled amplifier, resistance, capacitance, they are in series, where R will control the current and C will allow AC but block DC. Transformer coupled amplifier, so that we can match the impedance also. And direct coupling, straight away giving resistors, means there is no need to match the impedance or other parameter. So in coming to that one, there is again one more thing coming, push-pull amplifier, class B type. This is transformer type. This one I am going to explain you separately in 26C. So watch my video 26C, especially for push-pull amplifier based on transistor and maybe possible on triode or pentode valve also. Our syllabus is saying on triode and pentode valve, but that is now very old technology. So I am going to cover in transistors also, but you have to understand both. So single state transistor amplifier, already I have explained you, going a little bit detail that is needed. Sometimes examiner is asking you what is single state. Previously in exam, there was theory type exam, we have to write it with a diagram and text. You are luckier one, you have to choose the objective MCQ only, so you need a lesser efforts. But unless you know the circuit, you can't explain. So listen carefully. First, the single state transistor amplifier has only one transistor. You can see on screen, bias circuit and other auxiliary components are also there. Already I have shown you on screen. So when a weak signal is given to the base of transistor, you can see shown as a C in. From here the signal will come, and R1 and R2, they will divide a voltage and create a biasing level of base, so that it can work for full 360 degree with 180 degree, lesser or more than that. Depend on this value, this R1 and R2 divider, it will decide it is class A, B, A, B, C, or even D. So this is one thing, and that amplification factor is depend on beta of transistor. That alpha beta is also explained in previous slides. Go through that one. So this amplification of input signal to output signal is depend on IC. This collector current and beta and IB, base at current at base. So this will decide how many the amplification will come out. Now as the collector current increases, the voltage drop across the RC will also increase, which is collected as the output. Hence a small input at the base gets amplified as a signal of larger magnitude and strained at the collector output. Hence the transistor acts as an amplifier. Going continuously, you can see biasing circuit, this R1 and R2 and RC and RE, there are 4 resistors. They are making biasing network and stabilizing the circuit. With the help of these 4 resistors, a proper operating point will be defined. And same way, there is a C input capacitor which will take the AC signal and pass to the diode. This input voltage coming from the capacitor will be added in another voltage coming via R1 and R2 divider. This 2 voltage will go to the IB, and this IB transistor will amplify, and according to this conduction, RC resistance will change, and this AC will pass, we will take out from the CC. So this is CC, is a coupling capacitor we use to take signal out. This capacitor block DC but allow AC to pass. So this is also called blocking capacitor. We can take direct also, but we prefer capacitor to stop DC and take AC signal. Due to presence of this coupling capacitor, the output across the output free from collected DC voltage. So this capacitor is giving isolation to the transistor, so that due to this small negligible load from second transistor, it will not affect the previous transistor. So it is giving a stabilization. It is very much needed for next stages. So ammeter, we can use a bypass capacitor also in case of slightly variation in frequencies. This CE will bypass the other frequency so that it will give more stabilization, more better signal, and this is very little value. So this one also we can use in transistors. Going next, noise. What is the noise itself? Noise you can see in radio when you are speaking, in communication, in telephone, some background noise is coming, some equipment noise is coming, some charger power supply noise is coming, sometimes it's flickering. These all unwanted signal are called noise. They disturb, corrupt the parameter of the message or incoming signal, and we have to stop it. They are made in basically of 2 types. The first, external source, due to atmospheric noise, due to irregulation of atmospheres, extraterrestrial noise such as solar noise, cosmic noise. This is especially important for RF communication. And internal source, internal noise is due to power supply, due to filters, diode, disturb and loose connection of power supply, thermal agitation of electrical noise, or even short noise due to random movement of electrons and holes. They are also creating sometime noise, and this noise coming from microphone is being recorded in your some application. You can see. So there are miscellaneous noise also, flickering. Sometimes you are recording with your camera and backside tube is giving flickering to you. Resistance on time base changing its value. Mixer state due to some partially feedback in air itself creating some noise or oscillation. They are also part of noises. And these all noises disturb the sensitivity of the receiver, quality of the receiver. Even faithful production is not coming out. Even this time I am speaking a perfect volume, better quality audio microphone. But when this audio is coming to you, when you will watch this video, I hope this will be slightly distorted in audio quality because of my setup or other parameter or processing. Video quality, because whatever my camera is recording in processor, it will damage some color quality or some other parameter. So this is noise. So this performance are determined by the efficiency. So there are so many factors. I will discuss some other time later, but one thing is very important: signal to noise ratio. What is that one? So signal to noise ratio, just I am telling you brief only, not going in detail. When a signal is received and it has to be amplified, first the signal is filtered out to remove the unwanted noise and parallelly carrier information which is not required, which is available with a mixed frequency or mixed signal. We have to remove it, and this process gives distortion, losses to the original signal, and the ratio of information present in the received signal to the noise present is called signal to noise ratio, and this ratio has to be higher for the system so that it produces near to the pure information, much better quality, and this signal should not affect by any unwanted surrounding noise. Like you have seen, one noise came due to my mobile, my backside landline is there, that can also ring, and so many parameters are there, and even some shouting and other parameters will also come. So we have to filter out that one also. And this SNR, signal to noise ratio, can be understood as a P signal by P noise, means power of signal divided by power of noise. It should be higher. Higher the ratio, better the quality. So this is also expressed in logarithm basis using decibel. So SNR dB is equal to 10 log 10 P signal by P noise, and this decibel itself is a ratio, units. It is units for measuring a quantity, and this is 1/10 of the bell. It expresses a ratio of two value of a power or root power quantity RMS on a logarithm scale. Not going in detail because it is not required, just definition is enough to you. Going continuously. Feedback generally consists of two types. This one is also very important because this is a base of oscillator. Even in amplifier, AGC, ABC, they also require feedbacks. I can't explain here because it's a very big topic, but when the resistor topic will come, there I will take it again with more details. What are the feedbacks, how they are working, and they are basically two types: positive feedback or negative feedbacks. And the main difference between the amplifier and oscillator, because next topic is oscillator. The amplifier have one input, one output, but oscillator have no input, same output we are using as a feedback. So feedback term is very important to learn here because oscillator is starting soon, and same feedback is very important to control the gain and use for wide band of an amplifier. We have to control it. So this is very important. So this topic I am going to cover in 27 session. This topic is still continue, but I have to stop this topic here. Before I go somewhere, I have to ask a question to you. That as circuits are used to increase strong the input signal, what word will come? A, B, C, D. You have very limited time. Choose best answer. Time up. Yeah, answer is amplifier. So amplifier circuits are used to increase or strong the input signal. This one is today's session. Another question for you. In order to prevent distortions in the output signal after amplification, the input signal must be what? A, B, C, D. You can pause the video to read. Time up. Must lie with the negative and the positive separation level, so that it should be within the higher and lower level, so that you can amplify the whole signal. Otherwise, upper side will also cut, lower side will also cut, and you will get a distortion. So this one you will understand when next session will come, class of amplifiers. So thanks for watching my video. One more question is there. When the output signal wave shape become different from the input signal wave shape, that is called, there is no matching. Fast distortion. If wave shape is not the same, it's when there is a distortion. So this distortion is the answer. This may come in your ASOC exam. Note down it. So thanks for watching my ASOC tutorials. I'm giving so much efforts to make a videos for you. You supposed to be like it and subscribe to my channel if you are interested. You can advise to others also. Those who are interested to learn ham radio, it is a very important tool for them. So next session will be on difference between class A, B, and C amplifier explained. Please watch that one. Thank you very much for giving so much time to my video. Hope this video is very important to you. Have a nice day. Bye bye. See you again.